Hi, we're going to talk about how do we solve logarithmic equations today. Now, what we'll be learning is we look at the tools needed. We're going to solve some logarithmic equations, and we're going to solve some exponential equations that require the use of logarithms. Now, what do we need? Now, first, you need to remember two things. One is take logarithms on both sides, or you can remove logarithms on both sides. Now, deep diving into it, what does it mean by take logarithms on both sides? Assuming that I got 2x equals to, say, 5. And if I want to introduce logarithm, I can introduce log base 10 of 2x equals to log base 10 of 5. And they will be equal. Now, what do I mean by remove logarithms on both sides? Now, assuming that I have log base e, say 3x equals to log base e 5, 5y. And what it means is that I can remove the log base e and say that, well, 3x equals to 5y. Now, you can only remove it provided that the two bases are the same. And if we go on to talk about a logarithmic equation with the same base, and how are we going to try to solve it? We will still think of how to remove the logarithm. Now, first we need to recognize that if you look at this equation, all the base has 3. So log base 3, 2, I will write it as log base 3x squared when I bring the 2 up to the power, minus away log base 3x plus 4. And what do we do next is that we try to combine the two logarithms on the right hand side of the equation together. And when we want to combine them, we can have to use the quotient rule. So log base 3x squared over x plus 4, and that will be equals to log base 3, 2. Now, why do I combine together? It's because I want to remove the logarithm. Now, so if I remove the logarithm with the same base, I get 2 equals to x squared over x plus 4. And I can rewrite the equation without the fraction, which is x squared equals to 2x plus 8. Because I brought the x plus 4, I multiply both sides by x plus 4. And solving the quadratic equation, I will have x plus 2 times x minus 4 equals to 0. So I know that x equals to negative 2 and or x equals to 4. And what we need is, we need x, but we got to see whether this x is a valid number or not. Say, for example, x equals to negative 2. Do recall the definition of a logarithm. I cannot log a negative number, and as a result, I will have to reject minus 2 because log base 3 negative 2 is not defined. Now, because it's not defined, that is not possible. So my only answer is that x must be equals to 4 in this equation. And if we now look at the exponential equations that require logarithms, say 10 to the power of 3x equals to 36. Now, the question becomes, do we use the common log or do we use a natural log for this? Or on how do we even solve this? Now, 10 is base 10. So it is natural to use the common log, no pun intended, but this log base 10, 36 will be equals to 3x. Rewrite the equation, 3x equals to log base 10, 36. And then if I want to find x in the exact form, that will be 1 over 3 log base 10, 36. Now, this is the exact form. If you are needed to write it in the rounded off or corrected decimal form, now what you do is you key that into your calculator, and then you can write them in the decimal form if required. So for example, it will be equals to 0.519 in a tree.